Okay, in example 3, we're being asked to figure out whether the function f and the function h are onto or not. Are they surjective or not? So how do we investigate? So what is going to be the proof? First of all, you gotta decide one way or another. You want to decide, are you doing a proof? Are you doing a counterexample? So do you think the function f is onto, or do you think it is not? If you think it is not onto, then all you have to do is find a number in the codomain that does not have a pre-image in the domain. And in this case, you're going to fail to do that. This is because the function f of x is supposed to be onto in this problem. So let me show you the proof. So this is a comment, and the proof looks like this. So let the function f of x, or the function f with r going to r, and the function f is defined as 4x minus 1. What do I have to do? I have to find an element y in the codomain. So let's say y1 be in the codomain. So this r is that same r right there. Then what is its pre-image? Then its pre-image is going to be this. Then x1 has to be the fraction y plus 1 over 4. So then if I choose this x1, then that x1 is guaranteed to give me that y1 that I want. So let y1 be in the codomain, then its pre-image x1 will be this fraction. And it is guaranteed that when you put x1 into the function f, you're going to get the y1 that you started with. Okay, how do I check this? How do I verify that this y1 plus 1 divided by 4 is the pre-image? Well, all I have to do is plug it in. What would I get if I plugged in this x value into the function? So in other terms, what do I get when I plug in y1 plus 1 divided by 4 into the function f of x? Now the function f of x takes your input and multiplies it by 4 and then subtracts 1. And in this case, the input is y1 plus 1 all divided by 4. So I'm just basically grabbing the value that I figured out, the value that I chose, and I'm replacing x1 with it. And I'm kind of plugging it into the function to see what would happen. If I FOIL everything out and combine like terms, I'm going to end up with y sub 1 plus 1 minus 1, which is at the end y1. So this is indicating to me that if I plug in the x1 into the function, I'm going to get the y1, the image that I want. And that's exactly what it means to be an onto function. Okay, all I have to check is that y1 plus 1 over 4 is in the domain. Is that really in the domain? Yes, because my domain is real numbers. It includes fractions. It includes all the, plus 1s divided by 4, whatever. Everything is great. So this means that the function is onto. So therefore, the function f of x is onto. And that would be the end of the proof here. Now, if you're wondering, how did I get this fraction? How did I come up with this fraction that somehow magically, when entered into the formula, the function f of x, gives me back the y1 that I needed? Well, what I did is basically I went off to the side and I just kind of wrote y equals to 4x minus 1, and I just solved for x. So if I solve for x, I get y plus 1 equal to 4x, which means that y plus 1 divided by 4 is supposed to be the x. So if you give me a y coordinate, how do I know what its pre-image is? All I have to do is add 1 to your number and divide by 4. So let's try it out. Suppose that you give me the y coordinate. Let's say your y that you give me is 5. My job is to investigate if 5 has a pre-image. So is there a number in the domain that when it's mapped, when it enters the formula for f of x, gives you 5 at the end? The answer is yes. The number is basically 3 over 2. Let's try it out. Is it really possible for 3 over 2 to map to 5? Well, let's investigate. Let's plug in 3 over 2 into the function. We get 4 times 3 over 2 minus 1, which is 12 over 2, which is 6, minus 1, which is 5 at the end. So when you plug in 3 over 2 into the function, you get 5 at the end, which is the number you wanted. So that means the function is onto. And it works for any number 5 or whatever you give me. So if you replace 5 with 17, with -3, with square root of 2, my formula still gets the job done. Now, unfortunately, this is not always true. Not another function in the world is onto, and that's the situation that's happening in the second problem where they're asking is h onto. So in this case, the proof is going to say no, h is not an onto function. Okay, how do I know that? How can I guess this? Now, okay, first of all, what is the function h doing? So first of all, the function h starts with the integers and it gives me back integers. That's what it's doing. And the formula for the function h is that h takes the number that you plugged in, and what it does to it is it multiplies by 4 and then subtracts 1 to give you the result. But this time I'm going to pick a number y1, a specific number y1 that is in the codomain. I'm going to pick the number actually 5. Then let y1 be equal to 5. That is in the codomain for sure. 5 is an integer, so it belongs in the codomain. But unfortunately, there's no number in the domain that has that image 5. There's no number x1 that when it plugs into the 4n-1 gives us 5. Then no value n1 exists such that the h of this n1 would be 5. How do I know this? Well, here's the reason why. Because to map to 5, we need to plug in 3 over 2. Right? The n1 needs to be 3 over 2 to enter this formula for n-1 and gives you 5 at the end. But n equal to 3 over 2 is not an element of the domain. Remember, 3 over 2 is 1.5. It's a decimal. It is not an integer. So therefore, it is not part of the game. It cannot be found in the first set. If I cannot find it in the first set, then I'm not going to be able to grab it in my hand and put it into the function h of n to give you the 5 that you wanted at the end. So 5 is a guy in the codomain that does not have a pre-image. So therefore, the function h is not onto. Therefore, h of n is not onto. So again, to show that something is not onto, all you got to do is find a counterexample. So what does a counterexample consist of? It consists of finding an element y that does not have a valid pre-image. So in this case, the number 5 that you chose from the codomain, right, does not have a valid pre-image in the domain. Unfortunately, the 3/2 that you want is not going to be found in the integers. This is the reason why the function h is not onto. Now, if you carefully look at the function f and h in this case, they're almost the same. If you look at them, this one is 4x-1, this one is 4n-1. How come one of them was onto and the other one was not onto? It all goes back to the sets that you have in front of the function. That makes a huge, tremendous difference. As a matter of fact, the function f in this case and the function h in this case are not equal functions, even though they both multiply a number by 4 and subtract 1 to it. Why are they not equal functions? They're not equal because they're not playing with the same sets of numbers. One of them works over the real numbers, one of them works over the integers. So one of them has potentially a whole lot more input. The function f has every possible input that you can think of, any real number, whereas the h can only work with the integers. So that means the function h and the function f are not equal, and again, this shows that one of them is onto and one of them is not.